Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, we discuss about the second method of solving differential equation, that is by using integrating factor. So for the linear outcome, we will solve the first order linear differential equation by using this method. So first of all, our equation must be in this standard form. That is the first derivative, because it is first order only. So dy dx plus p is polynomial in terms of x, times y equals to q. So p and q are in terms of x. Right. So after we obtain this standard form, what we'll do next is to find the integrating factor. Okay. So this is after this the first step. So this second step, we find the integrating factor. So notice that we have p in terms of x over here. So this px we will use in order to find out integrating factor. That is by inserting into this formula, that is exponent of integration of that px, right? So after you integrate, you will get e power of the product of integration lah. So there will be our integrating factor. But in most cases, the answer will be in terms of ln. So if the answer will be in terms of ln, let's say e ln x, so we'll cancel out e and ln, and the answer will be x only. Okay, so we'll discuss in detail about this when we discuss the example later on. Alright, next, after we obtain the integrating factor, so in the third step, we will multiply this integrating factor on both sides of the equation. So remember the first, the step number 1 here, the standard form. So in the standard form, we will insert integrating factor on both left and right hand side. So that's what happened here in the third step. Okay. Next, in step number 4, we'll change into product rule. So basically, when we compare step number 3 and step number 4, we notice that on the right hand side, there are unchanged. Okay, it is still integrating factor times qx, no changes. The only changes are only in the notation. Okay, just a notation, no specific process actually, just changing notation on the left hand side. So I will highlight here what is the changes here in the left hand side. Right, so this is the original left hand side from standard equation. Right, so this is for standard equation, the original from standard equation, and then outside we have integrating factor. So what will happen in the product, the step number 4 product rule here, our standard notation for left hand side would be, first we will write ddx if the variable of the right hand side is in terms of x. If theta, so d over d theta lah, right? And then next, we will multiply y with the integrating factor. So if the integrating factor x, so y times x. If the integrating factor is ln or sine, so y times sine or that ln. Okay. So remember the step number 3 and step number 4, just the changing of notation for the left hand side. No specific integration occur actually. Just changing of the notation. Okay. So the only integrate process is in the step number 5. That is, after we rewrite the left hand side, so actually we will integrate the right hand side only. So the dx here we will bring to the right hand side, so dx, and then we will integrate both sides. So when we integrate both sides, we will cancel d on the left hand side, and d on the right hand side will be the notation lah. So means that we refers to integration with respect to x on the right hand side. Okay. So later we'll integrate step number 5. So maybe it is simple integration. Maybe the integration requires us to use substitution method, or for worst case scenario, maybe you have to use by part methods lah. Okay, on the right hand side. Okay, and then lastly, on step number 6, you have to solve. So what actually solve? So if you notice here, we are not doing anything on the left hand side, right? We only integrate on the right hand side. So what happened in the last step is, the integrating factor we will move to the right hand side. So we will divide lah. So what the product for integration on the right hand side, we will divide with integrating factor. So here actually we will divide with integrating factor. Okay, we leaving only x on the left hand side. So basically we can summarize the step number 1 is actually the standard form. Step number 2 is find integrating factor. Step number 3 is multiply. Step number 4 is rewrite in product rule. Step number 5 is integration process on the right hand side. And step number 6 is to express y in terms of x. Okay. So the integrating factor here, we will bring and we divide on the right hand side. So that's basically the process that will happen in integrating factor method. Right. So now we start with the example 3. So we discuss these 4 questions, or how to use integrating factor to solve it. So if you notice, 3 of them just a general equation, because we are focusing on the method first. And then lastly for D, we will substitute values and find the particular solution for that one. Okay, so we start with question A. Right. So in question A, so remember, as I already summarized the step on the right here. So the first method is actually to rearrange into the standard form. So luckily our first differential equation already in standard form. When we compare with this standard form, so this is standard form. So compare with the standard form, we will find that to find the integrating factor, that is the second step, we will integrate Px, right? So Px here in this case, we don't have anything in terms of x, right? So we assume it is on just dx. So if just dx, so integrate of dx will get ex. So ex will be our integrating factor. So in the third step, so as you notice on the right there, is mentioned that multiply if. So we multiply this integrating factor on both sides of the equation. So as I highlighted in the maroon color there, so es is the integrating factor they will obtain in the second step. So we multiply on the left and right hand side of the equation respectively. Okay. So next, step number 4. So it is the product rule. So remember, I already discussed a little bit what is the product rule. So remember, it is basically how we rewrite on the left hand side. And and you notice that there is no changes on the right hand side except where we just simplify, right? EX, so of surely it will be 2x lah kan. Okay, so on the left hand side, so what actually happened here is, so the standard notation here is ddx in bracket y times integrating factor. So this integrating factor we will put inside here, and then we write y outside here. Okay, so this is the standard notation, okay, for the product rule on the left hand side. So we just follow this step. So no actually process happening, just a rewrite. Okay, so next on the step number 5, we will integrate on the right hand side. So remember, left hand side we just rewrite, right? So we remove the ddx on outside there, so we bring dx to the right hand side, so means that we will integrate on the right hand side. So we will remove the d on the left hand side, so leaving only y and integrating factor. Okay, so now we're focusing on integrate on this right hand side. So integrate exponent to x, we know it is also exponent, and since the coefficient of x is 2, so we divide by 2, right? Okay, so lastly, in step number 6, express y in terms of x. So remember what is mean by that? Yes, that is, we will bring the integrating factor and divide on the right hand side. So since it is exponent, so no need to put 1 over, so just put a power of negative. So we bring to the right hand side will become e negative x. So we expand with the integration product from the right hand side. So expand with e to x will get ex, and then c, so c times ex, so it's ce negative x. So that will be our answer for question A. Okay, so as you compare here, so we'll get the same answer. Okay, so now we move to question B. So in question B, so our equation is not in the standard form. So remember, we have to rewrite in the standard form. So dy dx plus px times y plus equals to qx. So after we write in the standard form, so we know this will be only y, right? So apart from y, so the rest will be our px. So this px we will use in integrating factor. So in the second step, that is integrating, find integrating factor, we will integrate negative 1 over x. Okay, so we integrate negative 1 over x. So integrate 1 over x will get ln. So we'll get negative ln x. Remember, we can simplify e and ln, right? So what will we have? What will be the answer? I think some certain student will write negative x. Okay, actually this is the wrong answer. Why? Because actually we cannot simplify e and ln if we have something between e and ln. So notice here we have negative between e and ln. So with that we cannot yet simplify and cancel out exponent and ln. So to solve this problem, we will bring negative on the as a power. So e ln x power of negative 1. So and then we can cancel out e and ln. So we'll get x power of negative 1, which is 1 over x. So 1 over x will be our integrating factor for this question. So we will substitute this integrating factor on both sides of our differential equation. So remember step number 1, so we will multiply on both sides of the equation. So notice that the maroon color will multiply on the left side and the right hand side. And then step number 4. Remember step number 4, the product rule. So basically we just rewrite for the left hand side, right? Remember, and the right hand side, no actual process happen unless we have certain term that we need to simplify. For example, in this case, x and x squared we can simplify and we'll get x. That's the only happen on the right hand side. So the actual process happen on the left hand side. That is, we will bring inside 1 over x here to get, so y times integrating factor, and then outside d dx. Okay, so that's the standard notation for step number 4. Okay, next we move to the step number 5. So step number 5, actually we will integrate the right side. Okay, so here we already remove d dx. Okay, we remove d dx, so we bring dx to the right hand side, so it will become here, and then d already removed when we put cancel out with integral sign. So just leaving y and integrating factor on the left hand side, so we integrate the right hand side. Okay, the question here, how we integrate the right hand side here? X and sine to x. Can we use substitution method? The answer is no. So what method do we use? Yes, you notice that since we have u and dv, of course the method that we have to use is the integration by parts method. So remember the log-peg. So log-peg trigo comes last. So x will become u, and of course sine to x will become dv. So differentiate u ds and then integrate, sine will get negative cos. And then since we have coefficient 2, so don't forget we have to divide by 2. Okay. And then substitute into by parts formula. So don't forget, left hand side we still have y times integrating factor, that is y over x. And then left hand side, so remember the by parts formula, uv minus integration v du. So uv is sine times negative cos 2x over 2. Okay, so we move the negative outside. And then minus v du. So v du. Okay, so we have double negative here, so we can cancel out negative. And then we know integrate sine will get, and integrate cos will get sine. Okay, and then again we have to divide by 2 since the coefficient of x is 2. So here we already have 2, so divide with another 2, so the final answer would be over 4. Okay, and then apart from simplify this over 4, don't forget in the last step, that is step number 6, we will leaving only x. So sorry, we will leaving only y on the left hand side. So x here we multiply to the right hand side, over x will become x. So this x will be already, x will become x squared, and then this one doesn't have x, so x times sine. Also for c, c will multiply with x. Okay, so that will be our final answer for this question. Okay, so we already discussed the example. I hope you already got an idea how to use integration by parts method. Okay, we have another example. So now look at example C. So in this example C, again we have to rewrite in the standard form first for step number 1. So dy dx plus y times, so any terms in terms of x we consider as a px, so that will be our ps, and here will be our qx. So we notice that px is 2x over x squared minus 4. So we use that to find integrating factor, and then we integrate that one, and don't forget we have exponent outside So how we integrate to x over x squared minus 4? What method that you use? Do you want to use partial fraction? No, that will be too long. Why not use substitution? Right, we still can use substitution method, right? Because differentiate x squared will get 2x. So we can easily substitute with du, right? So we use substitution method in this case. So let u equals to x squared minus 4. So du we will replace 2x dx with du. Okay. So we can easily simplify our function. So now we become 1 over du. So straight away we know the integration will be ln u. Okay. In this case, between e and ln, it doesn't have anything. Okay, no negative and whatsoever coefficient. So we can straight away cancel out e and ln. So we get u. And then don't forget to substitute back u with x squared minus 4. So this is our integrating factor, x squared minus 4. So for step number 3, we will multiply this integrating factor on both sides of the equations. So rewrite like this. Okay, remember step number 1. So we just multiply left and right hand side. And then step number 4, the product rule. Remember, I already mentioned to you, we just rewrite, okay, ddx outside and then y times integrating factor inside. Okay, remember ddx, y, and then integrating factor. So basically this is the three items have in the left hand side of the equation. And again on the right hand side we will simplify. Okay, you notice that this one x squared minus 4, and coincidentally this one also divide with x squared minus 4. So we can cancel out these two. So we can simplify and we'll get x plus 2 only. So they will be easier, right, later, because we still have to integrate for the right hand side. Okay, so step number 5, we will integrate on the right hand side. So left hand side we already cancel out ddx. So we leaving only y as integrating factor. So integrate this one right hand side. So we'll get x squared plus over 2 plus 2x, and then don't forget plus c. Then lastly on step number 6, leaving only y. So we will divide our function on the right hand side, our terms on the right hand side with x squared minus 4. Okay, we write like this, and we notice that since we want to divide with x squared minus 4, so I suggest this term here also we put 2 as a common denominator. So means that these 2 we need to multiply by 2, we'll get 4, and then c will multiply by 2, we'll get 2c. So lastly we can combine together 2 with x squared minus 4. So this will be our final answer in the single term. Okay, so this is our simplest form for final answer. Okay, so I hope you get something for after we discuss all these 3 examples. So make sure after this you try to solve the tutorial question in order to grasp the basic concept how to use this method. Right, so don't forget we still have. Right, so next for the last question here. So y prime plus y over tangent theta equals to sine theta over tangent theta. So if you notice here, when we compare with our standard form, and by the way, y prime here is actually, usually we can replace with dy dx if we use variable x. In this case, it is theta. So actually we can replace y prime with dy over d theta. Okay. So actually it's already in the standard form. So we can straight away move to the second step, that is to find the integrating factor. So apart from y, the rest would be px, right? So actually here px is 1 over tangent. So 1 over tangent will be our px, so we will integrate that one. And the question here, how we integrate 1 over tangent? Remember the previous video, to integrate tangent we will use, yes, we use substitution method. So in order to do that, we have to change first tangent with sine over cos. So how about 1 over cos? Sorry, 1 over tangent. So 1 over tangent, it will be cos over sine. Okay. So cos over sine, remember, we choose denominator as a u. So in this case, denominator is sine. So u equals to sine. So du, differentiate sine, is cos theta d theta. So notice that cos theta d theta is actually already here. Okay. So we can replace this one with du. Okay. Right. So next, change into u. So it will be 1 over u du. And then we will know that integrate 1 over u is ln u. And remember, as I mentioned in the previous example, so when e and ln meet each other and there is no anything between e and ln, we can cancel out. So we're leaving only u. So don't forget, lastly, substitute back u with sine theta. Okay. So after we obtain the integrative factor, so don't forget, in the third step, we multiply this sine theta on both sides of the standard form equation. Apart from that, so notice here, on the left hand side, we also have another 1 over tangent. So here I already replaced 1 over tangent with cos over sine. So with that, I can simplify, and we'll get sine theta cos theta on the right side. Okay, next step number 4, just product rule, just rewrite the notation for the left hand side. So remember the three terms. The first d dx, or this one d dt, d over dt, and then y, and then integrating factor. So here integrating factor is sine theta. Okay, no changing here in the right hand side because we already simplified in the previous step. So actually we can simplify. Remember, the double angle for sine is 2 sine theta cos theta. So since here we don't have to, so when we change into sine 2 theta, we have to divide by 2. Okay, so after we change sine theta cos theta with sine 2 theta over 2, so this will be our function that later on we have to integrate. So we will integrate sine 2 theta over 2. So left side we already removed the differential sign, so leaving only y and sine theta. Okay. Right, so here we will integrate sine. So integrate sine, very simple, that is negative cos, right? So over 2 we already bring up at front here. So these 2 actually comes from the integration. So because we have coefficient 2 at theta, so you have to divide by 2. Okay. And then we simplify over 2, so that will be over 4. And actually this one is a particular solution. So we also substitute the value of theta and y. So when theta 0, y also 0. So y sin 0 equals to negative cos 0 over 4 plus c. Right. So sin 0, what is value of sin 0? So sin 0 is actually 0. And then cos 0 is actually 1. So 0 times y is 0. So the value of c is 1 over 4. Okay. So substitute into our equation. So remember this one already simplified over 4, and this one also, and then we substitute the value of c, that is 1 over 4 here. Okay, so now we move to the last step, that is step number 6. So in step number 6, so in this integrated factor, we will bring to the left hand side, right hand side, leaving only y. So y equals to 1 over, so since these two have 4, so we bring 4 at the front together with the integrated factor, that is sin theta. So inside here we put bracket, and since this one negative, so negative we put at the back. So 1 comes first, so 1 minus cos 2 theta. Okay, so that will be our answer, and compare with the suggested answer below here. So luckily we got the correct answer. Okay, so that will be our final example for this video. So the rest, I hope you can answer the question in the tutorial to make sure you fully understand how to use integrating factor. Okay, remember this method is not as simple as a separable method, so make sure you do lots of exercise to familiar yourself with this method. Okay, so that's all for this video. Thanks for watching, and don't forget, in the next video we will discuss about application of differential equation. So actually there are lots of application for differential equation, like the induction set. In the previous video we already discussed about population. Apart from that, also the example in the radioactive decay. So this one is actually physics. Also in the cooling and heating. Okay, also in the science, I'm not sure whether it's physics or chemistry, cooling and heating, and so on. There are another one, if I'm not mistaken, electric circuit. So electric circuit, one of the example. So we discuss this one in the next video, so stay tuned for that. Until then, thank you very much. Bye bye.